Hello guys, as all of you know that especially in inorganic chemistry, the exceptions are more important than normal trends because in almost all exams like JEE, NEET, GATE, CSR and at that all exams important exceptions are asked in questions. So we have compiled important exceptions of inorganic chemistry. So let's start. First exception is electron affinity of group 16 and 17. As we all know, actually electron affinity is inversely proportional of atomic size. As we go down in the group, then atomic size is increased. That's why electron density should be decreased. But due to exceptionally small size of fluorine atom, the electron affinity or electron gain enthalpy of Cl is more than F atom. That's why the trend in group 17 becomes Cl is the most electron affinity atom, then fluorine, then bromine, then iodine. Similar the case is in group 16. Group 16 oxygen have exceptionally small size. So it has exceptionally small size. That's why exceptionally small size of O atom, as well as in group 17 that is of F atom. So what happened? The electron density is increased. Electron density is increased. So we don't want to accept new electron. That's why electron affinity is decreased. Next exception is bond dissociation enthalpy of halogens. The actual answer is chlorine is the halogen which have maximum bond dissociation enthalpy, then bromine, then fluorine, then iodine. Means fluorine should come in between bromine and iodine. Next exception is the dipole moment. Actually the dipole moment of methyl chloride is more than the dipole moment of methyl fluoride. Another exception is bond angle. We can compare the bond angle of H2O, F2O and Cl2O. The bond angle of Cl2O is 111 degree. The bond angle is of H2O is 104.5 and then F2O is 103 degree. So maximum bond angle is of Cl2O, then H2O and last that is F2O. Then there is another exception, that is boiling point. Boiling point of HF, HCl and HBr and HI. The boiling point of HF is the maximum boiling point because of hydrogen bonding, then HI, then HBr and in the last that is HCl. NS3, PS3, AHS3, SBS3 and BIS3. These are the hydrides of group 15. When we compare the boiling point, then ammonia will come in between ASS3 and SBS3. Means BIS3 have maximum boiling point, then SBS3, then ammonia, after that ASS3 and PS3 has least boiling point. Then H2O, H2S, H2SC and H2TE. So again H2O is due to hydrogen bonding have maximum boiling point, then H2TE due to larger size of tellurium, then H2SC, then H2S. Another exception is for ionization energy, especially for second group elements. The ionization energy of boron is more than lithium, then beryllium, chlorine, oxygen, nitrogen, fluorine and neon. That is due to fulfilled and half-filled orbital configuration, stability of fulfilled and half-filled orbital. Third period, the aluminium is more have more ionization enthalpy or ionization energy compared to sodium. So sodium is the minimum, then aluminium, then magnesium, then silicon, sulfur, phosphorus, chlorine, argon. Then atomic radius. Atomic radius, as we go down, then we know atomic size or atomic radius is increased, but in the case of Ti and ZrHf, when we go especially in d block elements, then titanium to zirconium, obviously zirconium have higher atomic radius, but zirconium and hafnium have almost same atomic radius. We know that 3D and 4D, when we compare 3D series and 4D series, then 4D series have higher atomic radius, but 4D and 5D as well as 5D and 6D have almost same atomic radius. This is due to lengthenoid contraction and actinoid contraction. Lengthenoid and actinoid contraction. Actinoid contraction. Then group 3, scandium, yttrium and lanthanum, 3D, 4D, 5D. It has it is a similar train, no exception is there. 3D, 4D and 5D, because your lanthanoid contraction does not occurs in these elements, scandium, yttrium and lanthanum. It occurs after the lanthanum. Then atomic radius of boron family. Yes, there is also exception. The exception is that the aluminium have high atomic radius compared to gallium. We all know that is due to poor shielding effect of d and f orbital. Then ionization energy of boron family, we can compare like that: boron, then tellurium, then gallium, aluminium, indium. So that not tellurium, that is thallium. So boron, thallium, gallium, then aluminium and indium. So boron have maximum ionization energy. That is also due to inert pair effect, or you can say poor shielding effect of d and f orbital. That's why it affect the size, and that's why it affect the ionization energy. Then group 14 element, the ionization energies: carbon have maximum, then silicon, then germanium, then tin. But lead is the exceptional case, that lead has more ionization energy than tin. In group 15 there is no exception. Then 3D series ionization energy, there is also exception. That is an exceptional case. Especially exception is present in vanadium, cobalt and nickel element. Then in coordination compound there are good exceptions: PtCl4 minus 2 and PdCl4 minus 2. These two compounds whose coordination number is 4, with strong field ligand or with weak field ligand, every time they show dsp2 hybridization, and they have square planar diamagnetic non-polar structure. Then COH2O6 plus 3, CO oxalate 3, that is always they have your D2sp3 hybridization. Coordination number is 6. In p block element, SF6 is kinetically inert, it cannot hydrolyze. So BCl4 minus BBr 4 minus Bi 4 minus do not exist due to steric hindrance. Because of larger size of Cl, Br and I, they cannot exist. So there is steric hindrance is present. So that's why BCl3 plus Cl minus, there is no reaction. There is no reaction. Bond dissociation energy of carbon have higher bond dissociation energy than silicon. Similarly, nitrogen have lesser higher bond dissociation enthalpy due to interelectronic repulsion. Nitrogen have less bond dissociation enthalpy. We are talking about N single bond and PP single bond. Then then OO and sulfur. Oxygen single bond oxygen have lesser bond dissociation enthalpy than sulfur single bond sulfur. Then fluorine single bond fluorine have lesser bond dissociation enthalpy than chlorine single bond chlorine. That is due to smaller size of these atoms. That's why higher they feel higher interelectronic repulsion. Another one is carbon single bond carbon, then nitrogen single bond nitrogen, fluorine single bond fluorine, and oxygen have least bond dissociation enthalpy. In group 1 elements, only lithium is the element can directly combine with nitrogen and form lithium nitride. So lithium when react with air, it form lithium oxide as well as lithium nitride. When we come on exception of density, then potassium have higher density than lithium. So lithium is the least, then potassium, then sodium, then rubidium, then cesium in group first element. For group second element, calcium have least, then magnesium, then beryllium, strontium, and barium. So calcium and beryllium are showing exception in group first. In the case of density, potassium is showing the exception. So these was all of exceptional cases of inorganic chemistry. These are very important. You can note down and learn directly. Thank you.